I'll do the introduction first. Okay. Michael, it says live in 46 minutes.
Oh no, on air now. Right?
Why? Live in 46 minutes.
No, you have to refresh it. We're already online. We're already on air now.
Oh, I see. I refresh it. I got it. So, Bray, after your talk, this talk by you will be archived in our what they call YouTube channel of the society. Huh?
Sounds good.
Yeah. So are we on, Michael?
Yeah, I can start anytime.
Okay. So a very good evening and or very good morning in the case of Mr. Bray Falls. All right. Today we will have a talk by Mr. Bray Falls, who is an astrophotographer and co-founder of the Starfront Observatory in the town of Rockwood in Texas in the USA. So on behalf of the Astronaut Society of Penang, we are very delighted and honored to have Mr. Bray Falls to give this talk, right? So basically, the title of this talk is Dark Skies on Demand. So actually, the title of talk to us is very dear to us because we want to have dark skies to have the nice astrophoto, right? So I understand just now from Mr. Bray, casually we were talking that basically now in Starfront in Texas, in Rockwood, they have already have 960 plus operating telescope already there. And he told me that every day more telescopes are being installed. So it's very exciting. So by the way, we know that in the year 2004, Bradford Robotic Observatory in the UK was the first robotic observatory for amateur astronomers, was already announced on the internet. Very exciting. And since that, a lot has happened. And now Mr. Bray Falls would like to explain to us his political viewpoint from the Starfront Observatory, which is the biggest remote observatory or robotic observatory in the world. Okay, so Bray, you have the floor. You have the floor. We are honored to have you. Yeah.
Well, thank you for the introduction, and thank you all for having me here as well. So you should all be able to see my screen now, I think.
Can see your screen and can hear you.
Awesome. Cool. Yeah. As you're saying, the presentation is Dark Skies on Demand, and I'm gonna talk a bit about all of remote observing, how we started the observatory, how remote telescopes work nowadays, and how it kind of changes the way people go about and do astrophotography. So for those who don't know much about me, my name is Bray. I'm from Cave Creek, Arizona in the United States, and I started doing astronomy when I was about 13 years old, and I'm 28 years old now. I got an engineering degree from Arizona State, and I worked as an engineer for a year, and then I left to just go do photography full-time, and I've been doing that for about 3 years now, and I'm currently living and working at Starfront Observatories. I moved out to start the observatory in May of 2024, and I've been living on site at the observatory ever since then. This is a photo of me on the roof of Building 10. Took that last June. Yeah, there's a big problem in astrophotography that we had noticed, me and the other co-founders of the observatory. One is that a lot of astrophotographers are limited solely based on one, where they live, if they have a good backyard or not to even set up a telescope. And if you wanted to get into remote observing at all, basically every option that existed on the market was prohibitively expensive for anyone to get into. And so there was almost just like no chance to get into doing remote astrophotography or deep sky astrophotography from somewhere dark for the vast majority of people. And we had all been customers of other remote observatories and kind of decided we wanted to approach this problem in the same way, but by making remote observing actually affordable for a lot more people than it had been before. That was kind of the idea, just doing a facility that was run by a bunch of astrophotographers with the average astrophotographer in mind. So when you're building an observatory, you got to pick a place to put it, which is one of the hardest decisions to make. And there were a lot of things to keep in mind. There's a lot of good dark Bortle 1 land in the US, but a lot of it isn't necessarily suitable for an observatory or for like a large scale commercial observatory. We ended up looking all over many different states: California, Nevada, Utah, Arizona, and Texas. And we ended up settling down in Texas by a small town called Rockwood, which has a population of like maybe 12 people. I think our observatory increased the population of Rockwood by 100%, honestly. And we probably have the most telescopes per capita now of any community, which is funny to think about. But this place in Texas, it was Bortle 1, so it was very, very dark. It had good clear sky conditions for a lot of the year. So we see typically between like 220-ish to 240 clear nights per year, depending on the weather. But also more importantly, it had a 1 gigabit fiber connection up and down, which we figured would be important for us because we intended to have a ton of telescopes moving a lot of data every night back and forth. So this place kind of offered a balance of good astronomy conditions, but also good scaling conditions for hosting a lot of people at once and letting it work. So 2 years ago, we started breaking ground out there in May of 2024. And these are some of the initial buildings that we started with. We started with 2 wooden buildings and 100 spots. We didn't end up getting a full 100 spots in the 2 buildings because our idea of how big a telescope would take up on the floor was a bit underestimated. So that's kind of how it goes when you're starting something. You don't know exactly how it'll go, but the first test was a success. We ended up filling out the buildings relatively quickly in about 2 months with nearly 100 spots. So yeah, the observatory has evolved quite a bit from where it is here. You can see there's the 2 buildings, but there's also a little outdoor welding station. This is where we used to weld our piers together when we were making them ourselves. It's now actually our shipping building, and I'll show you, this is a photo of the site now. So that little outdoor welding station now has walls and a roof, and it's grown by 3 times the size. Also, there's now 14 buildings on site and about 960 something telescopes, but the number changes a lot. I only counted last like a week and a half ago. So we're closing in on nearly 1,000 telescopes at this point. And even right now, there's 4 buildings currently under construction. But here in this second row, we've got another set that are currently being built. The foundations for all of them are poured. So it's grown by quite a lot. On average, I think 3 or 4 telescopes per day, which is, it's a lot of scopes, and especially it's a lot to see in person. So here's just some photos of the telescopes on site. Like I said, there are about almost 1,000 now, and these are just some of them. Every single time I install a telescope at the observatory, when the roofs open up, I go and take a photo of the person's telescope so that they have it, but also so that I have it, so I can see, all the setups at the observatory. So this is just a collage of some of them, and there is a ton. And here is just a set of images taken with some of these telescopes at the observatory. So this is from a website called Astrobin, where a lot of astrophotographers will post their images from the observatory, and these are just some that I sorted by images that were awarded. So there's probably like 7,000 or so images from the observatory posted to that website now. And inside of our Starfront Observatories group, on Astrobin, there's about 56,000 hours of exposure time logged in the last 2 years, which is an absurd amount of exposure time. I don't know the math off the top of my head for how long 56,000 hours is, but it is a lot of time. So yeah, all these telescopes have produced some amazing results, and idea we had that a lot of people would be interested in remote observing if it was only more affordable ended up being pretty true thesis. Yeah, today there's about 960 telescopes. Here's a photo of some of them running at night that I took. I think this was last July from building number 9. Yeah, we've seen pretty much every single amateur telescope setup you could have at an observatory or in a backyard. It ranges all the way from E-star smart telescopes or dwarf lab smart telescopes all the way up to large plane wave instruments and custom telescopes. Our largest scope we have at the observatory right now is it's a 24-inch f3 Newtonian. It's absolutely massive. The primary mirror on it must weigh like 150 pounds. And it's not even functional yet because it's so big that it's too big for our buildings. So we have to build a new building to hold this gigantic telescope in it. So it's not running yet, but soon there'll be a 24-inch Newt running at the observatory. Yeah, all of this became possible really in the last couple years. Amateur astronomy equipment used to be really expensive and really bad. Back in the day when it was only CCD equipment, a lot of it is really not affordable to the vast majority of people and also not as reliable. There weren't as many good mounts as there are today. There weren't as many good cameras, telescopes as well, autofocusers. So in the last, I'd say like 5 or so years, the average amateur setup actually became good enough to be able to be used in a remote observatory setting and not just inside of the backyard. And if you think about it, if you're doing backyard imaging and you're running your telescope from inside your house, it's basically the same thing as remote imaging anyways. And yeah, automation programs also got really, really good. Back in the day, there weren't many good programs. You'd use like CCDAP or MaximDL, things that professionals would use, but now we have things like Nina or Sequence Generator Pro. And so it's become easy to automate and it's become really easy to have a reliable setup that you could actually use at a remote observatory. So a lot of people do have doubts about this still. There's some notions that you do need very premium gear, very fancy stuff to be able to run at a remote observatory, but it's really not the case anymore. The distinction that makes the setup being able to run remotely is just that it can run consistently and automated inside your backyard. So people that have deep sky setups that you could set out in the garden, hit the play button, it does its thing, and then you wake up the next morning, is that makes it good enough to be in a remote observatory, because the difference between the home and the back garden versus the home and a place thousands of miles away is just the idea in your head of where your telescope is, essentially. There are a couple small things that make a typical backyard setup really nice for remote observing that you may not already have. Stuff like the ability to troubleshoot your system remotely, which usually comes in when you have to unplug cables, replug them in, or turn devices on and off, or having a dedicated PC to control the whole setup. So all these problems are really easy to solve technically, and usually people will just have like a smart plug or a smart power switch on their setup, as well as something like a Pegasus that lets you power cycle basically anything on your device to turn it on and off remotely. So you don't have to be there, and you can do most of the troubleshooting that you need to do from far away. There are also some things to consider about like your cable management. You don't want a setup that has a bunch of cable snags to be sent out to a remote observatory, because then you're not going to be able to physically, touch it that night to save your setup. So any good consistent backyard setup is going to work well, largely at a remote observatory. So here's just some photos of some setups showing the different types of computers people use out here, we see a ton of different variety, but mostly in these four categories. ASI errors are super, super common at the observatory. There's probably 200 plus ASI errors now, mostly from people that are travel shooters that are traveling to dark sky sites. And this is what they're used to using. So we ended up determining that they work quite well for remote observing back in 2024. And over time, ZWO has made some upgrades to the ASIR platform to make it really easy to connect to. So I think just now, recently in the last month, they added these to a remote telescope network. So it shouldn't require a VPN or any networking stuff to actually access the ASIR files or anything on it. And they ended up being super consistent. They rarely break because it's basically a Raspberry Pi, and Linux systems like that tend to be quite stable. We do have a lot of people as well that use Eagle computers. They have dedicated power supplies and cables integrated into this PC, so it's kind of like a PC designed for astronomy. They're quite common. It can be nice to have cleaner cable management. The most common PCs we have are either the B-Link or the Melee mini PCs here. These are little Intel nukes. And usually people will pair these with something like a Pegasus power box, and they work really, really well. Very infrequently do these break. The ones that break the most common are the Prima Luce Eagles. Yeah, when it comes to a remote observatory computer, it's mostly about it being stable and reliable and not having a lot of horsepower, because the functions of running a astrophotography setup aren't very intensive on a computer. I mean, case in point with the ASI Air probably has the least computing power of the different options, but it's also probably the most reliable. Either way, whatever runs in the backyard will work well as long as it is functioning. In the same vein, pretty much every telescope works for remote observing as well. I like to compare it kind of to just traditional photography. You can have a camera lens for many different scenarios, and it's basically the same way in the nighttime sky. Every telescope is a different tool for a different job, and they all can take really great images remotely, whether or not it's a large Newtonian or a smart telescope. Here's actually a photo of that large Newtonian I was talking about earlier. We had to move it and take it down, but there were a couple nights here where it was fully set up, and I'm kind of standing here for scale. So it's a big telescope. But yeah, the thing you really have to look for between whatever instrument you decide to pick is just that it's stable mechanically. So basically that it doesn't have a lot of slop in the focuser to where it's sagging and you might, lose focus throughout the night, or have a lot of image tilt from focuser sag. Also that it's stable with its collimation. This is a big issue as well. It's more of an issue if you're traveling with the telescope than if you have it remote, honestly. We have a lot of telescopes that are like Ritchie Creations or Epsilons or like hyper-fast systems that use mirrors. And we find it's very, very rare that we actually have to recollimate systems that you typically would have to collimate more in the field. But you definitely want something that, holds collimation, because from night to night, you want to be able to use the scope. Another common issue is people don't have enough back focus in their imaging train to fit all the things they want to fit. But in any case, when people are deciding like what telescopes to send and you have multiple telescopes, it usually makes sense to use your best telescope at a remote observatory, the fastest one, because it'll end up being the most productive. I do see a lot online that fast telescopes are good for light polluted skies because you can collect more signal quickly, but the same even applies for a dark sky site. The faster it is, the better. And you'll find even at a dark sky site, you'll probably end up wishing for more exposure time, because the bar and how faint of objects you want to shoot will just keep moving. So you'll always be struggling for exposure time, even when you have, thousands of hours. The one big discussion point on remote imaging that I think is still discussed a lot is whether or not, or what kind of mount you would need to go remote, whether or not you need a premium one, or a super expensive one. And we've found that it's really not the case at all. We have pretty much every single mount out there at the observatory. We even have custom mounts that people have manufactured themselves entirely, and made custom electronics, machined the housing, installed the motors, and those people can still operate quite well remotely. So yeah, premium is definitely not required. You don't need a fancy, gigantic, expensive mount unless you have a gigantic scope, of course, and maybe you do. But we have just an example. This is a Skywatcher Star Adventure GTI, which is like a small portable travel star tracker that was never ever intended for remote use. But we probably have 15 of them now at the observatory, of people that use them very consistently every single night and very, very rarely ever have problems, which kind of defies a lot of people's initial expectations for an observatory class mount, but they work really nice. The only important consideration when you're looking between mounts, obviously, is one, that they work well, but also that you can find where your mount is in space after there's a power outage. So we don't get a lot of power outages, maybe like 3 or 4 per year that usually come with the storm. But if I could paint a hypothetical scenario here where, let's say, the roofs are open and there's a brownout or a blackout while you're actually doing your observing, and your mount is, pointed somewhere in space, where it is until there's the blackout or the brownout. And then you wake up the next day, your mount is thinking, once it's powered back on, that it's pointed at Polaris towards the North Star, but it might not actually be there in reality. It's just what the software believes. So you have to be able to return the mount back to a physical known position in that event. And there's kind of 2 ways to do it. You could get a mount that has a physical home in it. So things like Ictron 770 or any of the ZWO harmonic mounts have a physical home. And on those mounts, you can just click a button. You don't actually need to see the telescope, and it's going to go back to its home spot without any issues. There are a lot of mounts that don't have a home. Stuff like the GTI, I don't think has a home, or the EQ6, the HEQ5. Any of the older equatorial mounts won't have a physical home. But usually in those cases, what people will do is they'll get a little camera, a ZWO planetary camera with a fisheye lens, and point it up at their telescope. And we call these peer cameras because we mount them to everybody's peers. But here you can see this guy with the GTI actually has a little red peer camera down there. So you can watch his telescope in real time. And this is a screenshot view from someone's peer camera in Building 3. And you can see nice wintertime Milky Way there. But when you have this, you can actually, see the position of the mount. If there is a power outage, you can re-verify and bring it back with the little hand controls in your software. So even mounts that, are older, don't have the physical home, can still be run reliably if you just remember to check where it is in space after there's a power outage. People do often forget to check, and that usually ends up with them having a peer crash. Yeah, there's a lot of other accessories to think about with a remote setup, and I'll just kind of brush through them quickly. For cameras, one big discussion point is monochrome or one-shot color for remote observatories. And in pretty much every case, monochrome beats out one-shot color. They're my favorite because you can shoot with the moon out, and that ends up buying you a lot extra clear nights per year that are usable. Being able to shoot hydrogen alpha or sulfur 2, because you can't necessarily guarantee it's going to be clear every new moon, and you want to take advantage of as many nights as possible. One-shot color is better for when comets show up, though. But it's the same with any traditional backyard setup. All these same rules apply. Things like the having your guide scope focal length being a third of the telescope's focal length, and watching out for differential flexure. All that applies at a remote observatory as well. For focusers, we find most people use a ZWO EAF, and they do quite well. But when they have heavier imaging trains, something that's more expensive tends to hold things up a bit better, like the Moonlight or Optech, the really beefy autofocusers. the way people organize their power system usually ends up being where they might get some downfalls in how their telescope runs. And I'll kind of explain the best way to actually power devices remotely. So at the observatory, we have a 120 volts wall connection. A lot of people will use one of these. It's called a UPS, or an uninterrupted power supply. So earlier when I was talking about mounts, I was describing how you could have a brownout or a blackout, and then your mount would forget where it was in space. One of these also solves that problem. It's basically a battery that detects whether or not there's a power outage. And if there is a power outage, it just continues to supply your system with battery power for that time period. And then it'll basically allow the mount to park itself, home itself, and for your sequence to stop. So you won't lose where your mount is in space ever if you use something like this. But usually, yeah, the whole setup is plugged into this with a CASA switch or TP-Link switch that lets someone turn on and off all of their devices remotely. And then from here, it splits off. And this is where a lot of people usually mess up their power. Some people will power their PC off of their Pegasus, and then they'll accidentally turn off their PC and have no way to turn it back on because it's, it's connected in the loop. And then they'll actually need someone in person to come turn their computer back on. So it's always a good idea to have like these super important components powered on their own trains so that you can't shut yourself off from your system forever. So the PC is usually best separate, and then all the Astro devices being off the Pegasus so you can power cycle them as needed from the PC while also keeping the PC on and not turning it off on accident. Super important. So here's some other setups at the observatory. These are all refractors. Refractors are by far probably the most common, as well as the ZWO AM5 harmonic mounts are the most common. There's probably, last I counted, like 390 different ZWO harmonic mounts at the observatory. So they're quite popular. And per capita, they've had the least issues, I think, of all of the mounts at the observatory. So yeah, these setups end up being probably some of the most consistent and some of the ones that require the least amount of work of all the scopes. There's some that we've installed years ago that maybe only need to be checked on once every year or so. Occasionally, mounts will slip out of polar alignment just from, it's impossible for those blocking bolts on any mount to stay rigid for infinity. So maybe, once every 6 months or a year, they'll need a polar alignment, but largely a lot of these systems don't need to be touched at all. Yeah, for any setup, my rule is basically if it works in your backyard consistently, it's going to work remotely consistently. It's just a mental leap that a lot of people have to make between having the scope right there to be able to tinker with versus far away. If you don't have to tinker with it, then it's going to work fine. Also, we do a lot of telescope tinkering here as well. So if anyone has any issues, we can solve them pretty easily. And one pitfall that's super common in remote observing is people like to change stuff on their systems all the time. And it is a very fun thing to do when you're a backyard imager and you're tinkering with your setup. It is one of the most fun things. But once the setup's remote, tinkering gets a lot harder. And it's better to have a system that is dedicated, that you don't change around too much, so you can actually use it to go and collect some images instead of waiting, troubleshooting, downtime, things like that while you're trying to switch gear or switch parts on a setup. And yeah, if something breaks, it happens all the time. We basically constantly have tickets. At any given moment, there's probably like 50 to 70 people that have some tech support issue ongoing that we are working on. And even at night, every single night, there's probably about 20 to 30 people that we have work to do on, if not, polar aligning new telescopes that are coming online. So there's constantly people that we're working on or working with to get their telescopes running. And we live out there full time. So I live at the observatory full time, as well as currently 3 other people. So we work basically all day and all night supporting the telescopes. it's a constant job as well, especially at night in the summer. We know when it gets dark, maybe at like 9:30 p.m. local time, we'll be working out there until midnight sometimes, just polar lining or troubleshooting people's systems. So the one big thing that remote imaging changes about the way you would do astrophotography is that it kind of opens up like a whole new world of creative possibilities beyond what you could do just from backyard or travel shooting. When you troubleshoot, or when I used to troubleshoot, it was not for very many days at a time. It's logistically difficult to go camping, for a month at a time. People have jobs and lives, and you can't go just live out in the middle of nowhere forever. So going out to shoot, typically you would say, oh, I want to go look at like a deep sky object, one thing. You would maybe pick something that's known about, or a brighter object, so that you could know what you're going to take a photo of. It would be a guaranteed result. And you're making that decision kind of knowing you don't have a lot of clear nights, or you don't have a lot of time to go take that photo. And you do also have the risk of like forgetting something in your setup, or the weather being bad, or any number of things going wrong. But versus when you're at the remote observatory, instead of thinking that way, you end up with a bunch of hours of exposure time on your hands that you might not know what to do with. And it kind of gives you the idea to go and take some photos of some weird things, or do more creative projects that wouldn't be possible just travel shooting, or be significantly more difficult while traveling to go shoot them. So you guys are all familiar with this, but the difference between what you can see from a Bortle 9 and from a Bortle 1 is very extreme in what you're able to capture. You can hit, a sky limited exposure in just seconds, versus from a Bortle 1, it might take you dozens of minutes to hit the sky limit. And this basically sets a cap on the types of objects that you're able to shoot. This is one such object here. This is the Nereides supernova remnant in Cassiopeia. This image took about 250 hours, and it was shot from a couple different observatories as a collaborative project, which we'll talk more about those later. But an object like this is one that's kind of strictly off limits to Bortle 9. You might be able to detect it at like a Bortle 5 with a lot of exposure time. But a dark sky gives you access to, this whole set of objects that really isn't possible from anywhere else. And even in narrowband, narrowband is often, it's a really good way to fight light pollution. But there are a lot of emission nebulas in narrowband that are also only visible from a dark sky site. It's not just good for, bright skies. So you do lose out on a set of objects, and you also have to fight this really bad exponential time curve when you're trying to get equivalent results from a dark sky versus a light polluted sky. I'm sure many of you have seen this graph before as well, but basically, more light polluted it is, it gets exponentially harder to match the results from a dark sky site. An hour from a Bortle 1 is trending on 40 hours from a Bortle 8 or a Bortle 9. Once you get down to like Bortle 4, then you start to see, really good gains. But it's a tough problem to fight, especially on the higher end of the scale. It ends up being such that it's usually more worth it to go drive somewhere else than to try to fight the problem of light pollution. And this also limits your ability to have time to go explore weird things as well. When you're just capped with this exponential curve, it's really a big issue or a big obstacle. Yeah, when you do have a bunch of clear nights and a bunch of free time, and you don't have to deal with setting up the telescope every night, and there's much less technical issues, you end up getting a lot more freedom to go explore and take photos of weird things, which I think for me, has been the most fun part of remote observing, is you're not dead set on maybe just looking at things that are cataloged objects, but you could go look at professional sky surveys or amateur sky surveys like this one. I've included the link to this sky survey here because it's a very interesting one if you're looking to plan objects to shoot or take photos of. This guy lives in Europe and he did this full northern sky narrowband survey in SHO. And this is just a screenshot of that view. So you can look through surveys like this and say, oh, what is this weird thing going on over here? Maybe it's not on a catalog, but you have so much exposure time, you could go take a photo there and just see what's going on. And you can go in and explore fun or strange different objects. That's honestly been the most transformative part of remote for me that I had the most fun with. I realized a couple years ago that the night sky wasn't very explored well in the oxygen 3 filter. And so I had shot a lot of objects at that point and I got kind of bored. So I decided, hey, let's go taking O3 photos in random spots. And so from doing that, we ended up discovering a whole bunch of different objects using the O3 filter. Here's a photo of one of these. This one was discovered by my friends Marcel, Yan, and Xavier. You may have seen this object next to Andromeda before. It was very popular. It won Royal Greenwich Astrophotographer of the Year, I think, in 2023. But this is kind of the object that inspired me to go out and take photos of weird spots in the nighttime sky. Because, yeah, it's pretty insane to think there may be a gigantic undiscovered nebula right next to the Andromeda galaxy. Once this was known about, I started surveying the night sky, and it was fun to go and take creative photos of all of those things. But yeah, this image here, I shot using this telescope. This is my main telescope setup at the observatory. It's a 3 RASA 8 telescopes with 3 monochrome cameras on it. And this image was about 550 hours of exposure time. So it would be very, very difficult to do if you were traveling and camping to get 550 hours. I was kind of cheating because I was using 3 telescopes. So in reality, it's more like 120 something hours of exposure time, but still you get the point. Yeah, this setup, I chose all monochrome cameras for it so that I could shoot every filter at once. So for a super faint object like this, I could use every telescope in O3 and get a super quick reading in the O3 filter in a quick amount of time. So yeah, it's been a lot of fun using this setup. But here are some other photos that people have captured and some photos of the setups they use to capture them too. This is the Elephant Trunk Nebula shot by Joe DeFabio. This one was actually shot with a 1-shot color camera, which is a pretty interesting result because he used some narrowband filters to get kind of the traditional orange and blue color palette. But this is an example of, a very common amateur backyard or travel setup. I think this is a CWO or William Optics 65 millimeter refractor. This one falls within the mini size at our observatory, so it's one of the smallest ones that we have. Here is NGC 6819 by Colin Nowick. This is just an open cluster, but exposing it in hydrogen alpha, which is something that isn't commonly done on open clusters, shows a lot of interesting details. He used a Newtonian here, this one on the left under the Milky Way, with a EQ6. I think it's an aperture and Newtonian is the one he used. So again, it's a very common backyard or amateur setup to have with the EQ6 and a Newtonian like this, but he's been running his telescope quite successfully the last couple months and producing some really, really cool images with it. Here's the Dark Seahorse. I don't know which catalog name this falls under. I'm pretty sure this is located in Scorpius somewhere, but someone might have to correct me if I'm wrong. Super interesting dark nebula, but again, this one has a bunch of HA in the background. A little bit of an unconventional thing to shoot with dark nebula, but with having a bunch of exposure time to blow, sometimes it's fun to do narrowband on objects that aren't commonly shot and narrowband filters. So you can try and do something creative that way. This one's 53 hours of exposure, and the guy's name is Brian Diaz. And again, a typical setup you would see all the time. This one's a FSQ 85 with a AM3 mount and a monochrome camera. It's a pretty cool result. This is SH21 by Jonathan Hill. This one is definitely in Scorpius. Very cool reflection nebula with a bunch of H alpha in the background. And this one is a bit more of a beefy setup. He has a SEM 70 instead of a harmonic mount. But yeah, super consistent setup. Jonathan has a lot of really, really nice images at the observatory, and he's done a lot of collaborative images as well, which about next. So I think the most fun part about being at a remote observatory, in particular at Starfront, is that it's very community focused. So there's a lot of people talking to each other. And it just so happens naturally that when you get a lot of astrophotographers talking to each other in the same place under the same skies, they'll find that, hey, we're all imaging the same thing. They'll decide, hey, why don't we stack together all of our exposures into one mega image with a ton of exposure time to try to get the absolute best result possible. And so that's what people do all the time here. They'll organize themselves into big groups. Sometimes, they might be smaller, like 6 or so people, but sometimes the group size goes up to about 30 people, I think is the largest collaborative that's been done. So they'll all point their telescopes at one spot. They'll all decide, hey, we're going to shoot these filters, and then run their telescopes on the same object for a series of nights. And that lets you basically turn your own telescope into part of a large virtual telescope array. And it turns your collecting power into something that's closer to a professional telescope than just an amateur telescope. And that lets you do a lot of really cool things that are basically impossible to do alone in terms of exposure time. So there's been a lot of collabs done. These are 2 of them. On the left, this is a Helix Nebula image that's got about 700 hours of exposure time. The 700 hours would take conservatively 2 or 3 years for one person to do alone. But in the collective group, this image really only took a month or 2. And if the weather was perfect, you could probably get this image done within a week or so with enough people. And they were able to see a lot of really, really faint features on the outside of the Helix Nebula, some of these older shells that are significantly fainter than the inner parts, and they were able to show them in quite a lot of detail. This image on the right is almost 2,000 hours of exposure time, which is insane, but it shows M81 and M82 here. They almost look like they blend into the background because the IFN is so bright. Yeah, this field around Ursa Major has some really interesting objects in it. This is the Vulcan Nebula, which is kind of an ancient planetary nebula or hot subdwarf type object. Super, super faint, requires a ton of exposure time along with all the IFN. So yeah, 2,000 hours would take you, an ungodly amount of years to be able to do on your own. But when you're in a big group, it ends up being quite trivial. Here's another almost 2,000-hour exposure image. This one's of the Squid Nebula in the constellation Cepheus. I cropped it in quite closely. The full-size image is pretty big, and it shows a lot of faint dust in the background, but I wanted to kind of zoom in and show the details on the squid itself because it has a lot of really intricate structure that's worth taking a look at. But yeah, 2,000 hours is absolutely crazy. Here's one. This was captured partially from some backyard setups and partially at the observatory, but in a collab with multiple people. This is SNRG 159.6 in the constellation Auriga. And this is, I'm pretty sure, the first optical image of this supernova remnant that's been done. It's a super, super, super faint one. And this one took about 300 hours of exposure. And this one's cool because they actually discovered a nebula. So this little bubble down here is a planetary nebula, and it was one that was undiscovered until this team of photographers went and took a photo in this area. That's one of the coolest things you can do. Taking photos in random spots, there's always a chance to discover something new, but also when working with the group and having a ton of exposure time, oftentimes it shows things that just weren't seen or weren't known about, and the amount of exposure time that one person could do alone. This is another image where someone did the same thing. There is a discovery in this photo somewhere, but it's quite a small planetary nebula, and I'm not sure I could pick it out. But this is a SNR G126.2 in the constellation Cassiopeia, and they used, like 1,200 hours of exposure time for this. I think this might be hard to see in the presentation, but there's a little blue bubble there. I'm pretty sure that's the new nebula. And a lot of new nebulas have been discovered this way from the observatory, which is really, really cool to think about. Our first collaborative image, we actually discovered one. This is another one we did. I think this is the second project we did at all in the observatory 2 years ago. This is the Triangulum Galaxy Messier 33 with about 1,000 hours of exposure time. And it shows a lot of really, really faint star forming regions all throughout with a ton of detail. One of these was discovered only a year, 2 or 3 years ago by one of my friends in Spain. His name's Alex. There's a small little half moon O3 nebula right here that's formed by a Wolf-Rayet nebula. It was discovered by an amateur. So, if we were a couple years earlier, maybe we would have discovered this, but Alex had beat us to it on that. So here's just a screenshot showing our Discord forum where people will tend to organize and form these projects. There's about 3,000 people in our Discord now. And there's a link to it here as well as on our website if you want to join the Discord, sign up and see what's going on. But yeah, here is basically where the community exists and where we talk about and plan our projects together. So you see there's the Squid Nebula project. This one ended up getting finished. Right now we're working on Markarian's chain. We have a little over 2,000 hours of exposure time on Markarian's chain right now. So we're working on stacking the image currently. And stacking these images is no easy feat when you have thousands of hours of exposure time. There's one guy at our observatory that has like a custom server with a bunch of custom scripts as well that he uses to do the pre-processing. And without him handling all of that, it would be pretty much impossible because we would probably need some kind of supercomputer at the observatory to do all of the stacking. Yeah, when you're looking at this, it is an important question. How much time is enough for an image? And it's hard to decide. And a lot of people put numbers on it. But I typically find whenever you think it's good enough, the qualitative assessment is better than the quantitative one because oftentimes you'll end up in the weeds, especially when you're doing collaborative imaging. There'll come a time when you're like hundreds of thousands of hours of exposure into an image and you're like, how much more do we need? What typically happens is everyone kind of gets bored after a couple thousand hours and you start to hit what's called the diminishing returns, and then we'll decide it's good enough. Basically, to half the noise in an image, you have to double the exposure time. So you get to a point where you've doubled the exposure time so much that the next noticeable gain in your image ends up costing too much time. So for a collective, once you get up to 2,000 hours of exposure time, the prospect of going 4,000 hours to get half the noise or a quarter of the noise is a bit too expensive time-wise. Yeah. One important thing to mention as well is how people actually end up running their telescopes. I know I pointed out earlier that there's some good new programs like Nina or Sequence Generator Pro. Nina is by far the most common way that people end up controlling their telescopes out here at the observatory. And then you basically have to also access your PC while it's over here. And you have to use a remote desktop client to do it. I really like Chrome Remote Desktop, but there's things like AnyDesk or TeamViewer or RustDesk that also give you a good connection into your telescope. Yeah, that's how it works. So you'll have your home computer and then your telescope computer, and you have to basically pretend like you're in your telescope computer to control it as if it were local. Some people get really crazy with the degree to which they automate telescopes here at the observatory. We have files on our servers that communicate whether or not the roofs are open. So some people will have their Nina sequence set up with the status of the roofs. and then they'll have it on a constant loop. So basically the telescope knows when the roof's open. Once they open, the telescope will go do its thing. And then once the roof closes, it'll park itself. And it can do that like perpetually in a loop for months at a time to where they don't even need to check on their telescope. I kind of like checking on my telescope, but for some people, going full off the deep end into automation is part of the fun and the hobby. And yeah, at any time, you can see what's going on at the observatory from our status page. The link to it is just status.starfront.space. And we have live cameras here as well as our all skies. So you can see what's going on at literally any point in the day here at the observatory. You can also just like see us working in there. And it'll give you an idea like if it's clear, what the weather's like, or if the roofs are open or not. Sometimes people will go to start their telescope, run it, and they'll say, why can't my scope see any stars? And then they forget, oh, we should probably check if it's clear or not. And then they'll come here and see that the roofs are closed and the telescope's just looking at the roof. I do that to myself a lot, actually. One big question when you're running a remote scope is how to effectively do image calibration, because calibrating is a bit easier to get your head around locally, but when it's remote, there are some extra difficulties. Most of them are solved by having a flat panel. This is basically like a motorized cap that goes on the front of your telescope with the LED panel inside. And it lets you take photos of an even white surface to do your flats, but you can also close it to do your dark frames. A lot of people don't use flat panels at the observatory, but what they do instead is they do sky flats. So just taking a flat on the evenly illuminated sky works well. And for darks, what we do is every full moon, we actually have a sign up sheet where people can sign up to put a lens cap on their scope. And then we walk around and put lens caps on everyone that wants to take dark frames or bias frames, which are just exposures of pure blackness. And this way, a lot of people are still able to do calibrations without having to pay for a flat panel on their system. A lot of systems can have flat panels of them as well. Things like the RASA or a really large telescope might need a trash bag over the front to really calibrate it. Yeah, getting your data home back to your home PC ends up being really, really simple from our observatory just because of the internet speed. What I do is I just set my file save path to Dropbox folder. You could use Google Drive or any other file transfer service functions. And as soon as the sub gets taken, I just immediately upload it then and there. So when I wake up the next morning, all of my data ends up being straight on my processing computer, and then I can stack it whenever I need to. And some observatories, you do have to time when you transfer your files because the internet is so sparing in rural locations. But from our site, it's very, very fast. It's the fastest internet that I've ever had, and I've lived in, various cities. Yeah, when people send out their telescopes, the way that it works is there's two ways people tend to bring scopes into the observatory. They'll either ship them or they'll come drop them off. And people have come to drop off stuff from very, very far away. We've had people visit with their families from like London and Paris and to come bring their telescopes in person with their family, which is really cool to see. But most people, they end up just shipping their telescopes in boxes, which there are a lot of particular things to pay attention to when shipping a telescope. And we have a FAQ on our website where we kind of break down all the things to pay attention to, like keeping your mount clutches open when you ship, or like engaging your mirror locks on an SCT when you ship it. A bunch of things to take note of. But yeah, once we get a telescope in at the observatory, we end up setting it up here in our shipping building. And this is just one telescope I worked on a while ago while I was installing it. And we basically build it out to whatever instructions you have. Every customer or every user has very particular notes on how they want their own telescope set up, because we're astrophotographers and we end up being very particular about how our systems go. So we take a lot of care in that. And then we end up we set up the scope in the OCA in our shipping building, then we bring it over to one of the buildings where we choose where it goes in the observatory. And then once there's a clear night, we end up polar lining the telescope, and then we send you a message once it's running, and then hand over the keys essentially and let you start imaging. That's how install works. Shipping, yeah, this is, especially from Penang, will be an interesting thing to figure out. With customs in the States, usually it's best to declare that any telescope or something is a personal item, because otherwise the US will try to charge a customs fee. But in either way, you want to pay very careful attention to how you pack a telescope and check the shipping fact as well. This is an example of an overpacked telescope that someone sent out, but everything, was delivered safely. So there really is no such thing as overpacking, but underpacking can be quite bad. But they left like no spare space for any of their things to bounce around. And most people's telescopes do show up in good shape. We've only had one broken telescope before. It was a Meade LX200 8-inch SCT that we opened up, and this person didn't leave any space in between where their SCT was and the box that it was in. So when we took it out of the box, I just heard a bunch of glass moving around inside the OTA, and I, of course, took the lens cap off to find a shattered corrector plate, which was sad. Luckily, he was able to get a replacement because it was insured. So insurance is an important thing to take note of as well, because you never know what happens, when you ship a telescope. One interesting option, if you don't want to ship a telescope or deal with that headache, is we actually now rent out telescopes at the observatory, in particular the C-Star rental telescopes. Smart telescopes have kind of like exploded here in the States in terms of popularity in the last year or so, as kind of like the way to get into astrophotography. And so we've been kind of trying to ride that wave at the observatory by hosting a bunch of them remotely. And they actually work super well. ZWO put in a remote telescope connection network into the C-Star app. So you can literally just log in from wherever directly from your phone to use a C-Star to take photos. And these are only $99 a month is what we charge for them now. But you can actually take some really, really great images with these. Here are some that I shot. This one was with the S30, just a plain S30. These rental ones we use now are S30 Pros. So we're constantly changing the ones that we have for rent at the observatory. But yeah, this is the Horsehead Nebula. About 6 hours of exposure I spent on this. This is Pleiades. This was shot by a user named Heidi Grady at the observatory. And yeah, the results you can get with just a smart telescope now basically rival what you could do back in the day with, a rig that was maybe $3,000. So by far, it ends up being the best way to get into astrophotography. So there is an easy way to both get into astrophotography and to easily get into remote imaging to try it at our observatory by just taking control of one of these. And the fun thing is, if you were to try it from Malaysia with the time difference, you would probably be starting your telescope around 10 or 11 a.m. local time. So you'd be doing astronomy in the daytime instead of at night, which does have its advantages. Yeah, that's the whole presentation. So I think there is a question segment next from YouTube questions.
Yeah, Bray. Yeah, we have a question session. Dr. John, can you read out the question if there are any?
Okay. All right. So first and foremost, thank you, Bray, for the presentation. I thought it's
amazing presentation, very enlightening.
It's actually quite amazing, the things that I learned from this presentation. Okay. So by the way, for those who are watching now, please feel free to leave any questions that you want, and then I will read it out for Bray. Okay. Because at the moment, I only have one question from the chat. Of course, I myself have some questions as well that I can add later on. But let's address the first question then. Right? I think the first question is actually just from Dr. Chong himself. Yeah. So Dr. Chong asks, where will be the Starfront Observatories south? Where is it going to be located? And why is this location being chosen?
Maybe before Bray answer the question, I give my comment is that for us in Malaysia, in Asia, we are very interested in this Starfront Observatory South. because it's closer to home. And for us, we have been observing the northern hemisphere a lot. So we want to access to the southern hemisphere. So, and if there's a location that's not too far from our countries, it may be not only we will rent the observatory in the south, but we can actually visit there also.
Yeah, I can't say exactly where yet, but it will be 31 degrees south and in Australia.
Yeah.
So, yeah, Australia. I went down there last April, like April 10th to the 17th, and I went and looked at a bunch of places and judged the site quality in the night sky, and we found a really nice spot. So I think probably in 3 or 4 weeks, I'll end up being able to say exactly where it'll be because we'll have acquired a spot.
Yeah, that would be great. Yeah, for people watching the talk, just for information, Rockwood, Texas is about 31 degrees north, and this proposed location by Bray is 31 degrees south. It just complement Rockwood. You see, yeah.
Yeah, it was completely unintentional too.
About the
It's
same,
funny, I
31
checked my-
north and south. Yeah.
Yeah.
Okay, I want to ask maybe a few questions while waiting for if there are any questions from the members. So once again, members, if you're watching this and you would like to ask any questions, please do so, right? So myself, my first question is that, so I understand that you started this out with a few friends, but where did you get like some funding from government, or is it like just private funds? How did you start out, like financially to make this happen?
It was self-funded between me and the other co-founders, so entirely bootstrapped just with us.
I see, but I mean that must be quite risky, isn't it? I mean, because you at that point you're not sure how will it turn out, how are you going to generate income? I mean, what made you push you to start this even?
Yeah, it is risky, but we were all like very highly confident that it would work out. Me and the other co-founders as well had been at a company in the past called R-Sky, which is, I don't know if you've heard of it, but they kind of do like SDA or satellite tracking work. So we had a lot of familiarity with like the professional side of like the astronomy world, but also the amateur side as well. One of our other co-founders, Dustin, was the CEO of OPT, which was like one of the largest telescope stores. So we were like intimately familiar with like remote observing, the telescope market, professional side of astronomy. And so we had also all been customers of remote observatories before as well. So we just kind of became very confident that this would work out and it was worth the risk.
I see.
It
So
ended up being
there
so.
was demand when you started this already, right?
What was that?
That means you already had a demand for this kind of services when you started.
Because John, I can see there's a two big attraction to Starfront, because number one, they have Bortle One Sky, all right, and number two, they have a very competent and dedicated team of people to run it. So I think the investors and the amateur astrophotographers are confident in it. You see, yeah.
Yeah, getting demand at the very, very start was interesting because we pre-sold the spots in the first buildings without the buildings existing yet. So we were just kind of like convincing people that this would be a thing. And so getting those very first people was tough. And I think once those people were in, there were a lot of people waiting on the sidelines to kind of see how it would go before they sent their telescope. Because a lot of telescope owners are very smart and they're probably going to wait to see how it goes before, sending a telescope themselves. And that ended up being the case.
I see. Okay, so we have two questions here. Okay, the first one is from Paffarrington 2919. Okay, so the person says, "Hi Bray, what is your most common setup in Texas? Camera and telescope. Is a filter wheel that important?" So that's the question.
The most common setup, I would say, would be a ZWO AM5 with like the ASCAR FRA 400 or 500, and then the ZWO 2600 mm with the filter wheel on the back, and then either with an OAG or a guide scope is by far most common setup we have. That combo is, if you ignore the ASCAR and just say like the 2600 mono with the filter wheel, and then the AM5 and just pick and choose any refractor, that's like the bread and butter setup at the observatory, and there's hundreds of them. A filter wheel is decently important depending on what you're trying to do. There are some setups that don't use them, like the RASA setups that I have. They don't have a filter wheel, and some people are just shooting one-shot color. In those cases, you don't really need one, but if you're using monochrome, it's best to have a filter wheel for sure. But if needed, and if you do have a filter slider and you do have filters, we do actually change out filters for people by hand all the time. They just like submit a ticket in our ticket system and ask us to change it. And then within a day or so, we'll swap a filter for them.
I see. Okay, I hope this answers the question. Okay, so the next question is from Sivaraj Gopalkrishnan, 7682. I think he has two questions. So the first one is there northern light image where I saw telescope arrangement with Milky Way photos?
Maybe John, you repeat the question?
Okay, so the person asks, is there northern light image where I saw telescope arrangement with Milky Way photos? I think maybe was there a Milky Way photo that, so he's asking, is there like some sort of northern light in there?
Yeah, we did get aurora from the observatory 3 times in the last year. Yeah, I wonder if there's a way for me to show it. I think on our Instagram, I have videos and time lapses of the aurora we've seen at the observatory with all the telescopes. If you just go to Starfront Observatories and scroll through the videos, you'll see. But yeah, we had a couple really big aurora substorms this year that made it all the way down to Texas.
Oh,
you could see it naked eye. Yeah.
Okay.
Did not expect to see them, but it was very cool.
Okay. Sivaraj has a second question. So he asks, our Malaysian weather continues sudden changes like rain or cloudy. Is the weather there stable and predictable, especially for rain?
For most of the year, yes. There is a rainy season in Texas that goes from April to mid-June. It's the storm season out here. So during that period of time, the weather becomes quite chaotic and we'll have thunderstorms. But after that, it becomes very dry for most of the year.
I see. Okay, yeah, because Malaysia, we are always plagued with a lot of rain and clouds. It's very common that we have this problem over here. Okay, so if there are any questions, please feel free to ask more. So while waiting, I'll just ask another question for myself. Okay, I'm actually quite interested in when you mentioned about the collaborative images. So that means you have like multiple telescopes observing the same thing, right? So can I ask a little bit more about how you do it? Is it do you just stack the images, or do you actually consider like baselines, like how far these telescopes are away from one another? Something like radio interferometry, right? But optical. Do you do that, or do you just stack the images?
We've just stacked so far. Optical interferometry is pretty, I think it's over our heads, probably. I think you might be able to do some parallax between 2 images for something like an eclipse, but for deep sky work, we've just been stacking the individual frames together to boost the signal, essentially.
I see. Okay. All right. I have another question. I saw that, I remember you have a chart where you drew, I think it's the integration time versus the Bortle number of the sky, right? I find that quite interesting. How did you generate this? I mean, what is there like a scientific basis and equation behind this, or was this empirical results that you obtained?
This was a graph that I got from someone on Reddit somewhere. I just look up Bortle time versus signal to noise ratio.
I see. Because I'm just curious, because I myself, I'm a university lecturer, so sometimes we do research, and I'm just wondering, because this is like you're trying to study the integration time versus the Bortle, so could it be reversed? That means if you do not know the border of the sky of one place, and you just try to take an image and then you wait for the integration time, and you can have like some sort of something like a standard that you can compare to, and with that standard comparison, you could find out, what's the border of the sky of that location.
Like a signal-based way to measure the light pollution level. That would be cool.
Have you thought
I
about
wonder if
this?
there would be. No, I haven't. I haven't had to shoot from light pollution very often. I kind of forgot about it.
I see. Okay, I don't know. I just thought when I look at that
That would
chart.
be a cool idea. I wonder if there'd be a way to do that, like set a standard.
Okay.
Dr. John,
Yep.
Dr. John, maybe I can make two comments, and then
Sure.
I'll ask Bray another question.
Go ahead.
So the first comment, of course, we know that many of the amateur astronomers have been taking deep sky objects with their own single telescope in a dark sky location for up to hundreds of hours. But it's the first time I hear thousands of hours. But he say, not to say cheating lah, you take with 3 telescopes altogether, maybe about more than 1,000. I mean, 1,000 hours. But in each individual telescope, it's actually a few hundred. So it's done. The other one is collaborative effort. If I understand, is that basically you have one person taking the same object, and then you have many people take object. You add on more photons. When you add more light, maybe the faint features will come out. That's the advantage. But actually, previously we have a Malaysian astronomer, Dr. Yip Ping Kok. He did his PhD at the University of Sydney in Australia. He did his PhD on the SUSI telescope, SUSI. So you have two, I think about 10-inch switch cassegrain, few hundred meters away, and they measure the long baseline, and they can mesh the wavefront. But we know in optical light, wavefront matching is difficult because the wavelengths are very short. But they were able to measure the diameter of some of the binary stars, which they cannot split it. Now they can split it, you see. Whereas in radio astronomy, they're using long radio wavelength. Although the baseline is very long, they can mesh the wavelength using the atomic clock. But they are trying for long baseline optical interferometry. But that is another thing. So my question is that Bray mentioned just now about this hydrogen alpha and also sulfur 2 line. What about if some of the people who rent the telescope or put telescope not only for astrophotography but maybe on research project? Maybe they're keen on taking only the spectrum of the stars and so on, or some research project, or maybe to find out new supernova exploding in the galaxies. So I think in this setup, in Starfront, I think it's doable. Research project, yeah.
Yeah, we would take any research projects if people wanted to send them. We haven't had a university yet. I think we had some inquiries from one in Japan about like a satellite tracking system at one point, but yeah, so far we don't have any universities, but I would love to have any of them, even weird projects like radio or stuff like that. It would be great.
Yes.
Yeah, because I saw that you mentioned that there was a planetary nebula discovery, or in fact, multiple ones of them. And I'm just curious, do researchers take these and publish in papers? Or how do you handle these things like discoveries,
So it depends on the type of object. Most planetary nebulas go through, there's 2 guys. One, his name's Quentin Parker, and he maintains a database called HASH. I think he's at University of Hong Kong, but it catalogs like most planetary nebula or planetary nebula candidates. There's a French guy he works with, his name is Pascal Ledoux, that kind of catalogs most of the amateur discoveries, and he kind of feeds stuff to Quentin, and then from there they'll research, like do spectra or confirm or deny planetary nebula candidates. For supernova remnants, it's a bit harder. There's one professor most amateurs work with, his name's Robert Feason at Dartmouth, and he does some spectra of supernova remnants that are amateur discoveries, and he occasionally writes papers kind of collecting a bunch of amateur supernova remnants into one paper so that they can all be published. A lot of objects though are difficult to get published if they don't fit into one of these 2 bins that are easy to study. And so a lot of objects out there just aren't officially cataloged anywhere. They're just in people's photos on the internet somewhere.
I see. How about I mean, you mentioned supernovae remnants, right? How about supernovae? Because, like for example, I did my PhD back in the University College London, and they actually discovered a supernova sort of like by accident. It was like a student project where, you know, the students, astronomy students, they're supposed to do their annual, like, it's sort of like a laboratory, astronomy laboratory project. They go to the observatory, they take images of galaxies, and the lecturer actually noticed that there was a bright spot, you know, in the image. So they ended up discovering the supernovae. They alerted the supernovae community, and they published a paper. I'm just curious, do you have something in place like this that you could, you know, because I'm sure if you're there are a lot of images coming through, you could potentially set up something that could help to identify if there are anything interesting in these objects, I suppose.
That would be a smart idea. Currently, no one is monitoring like in a consistent way across the observatory. I'm sure some people do check their data, but yeah, maybe something would have been missed at one point, you know, if people don't blink through their frames and look for a new bright spot. I mean, people are looking at pretty much every part of the sky every night. I think eventually something would happen if people had a consistent way to check. Maybe there's some script or something people can feed their FITS files into to look for new things. How did you guys go about looking for new ones other than just random chance?
Well, I mean, I myself, I'm not a researcher in optical astronomy, so I do not know. I mean, or I do not run codes that do that. But usually, I mean, currently with AI, you know, object detections and a lot of image sort of like checking software. I mean, there are people who do that. But of course, it really depends on the kind of field and where do they. When do they get it? So the reason why the UCL one, the one that I was talking about, they discovered it is because the lecturer himself knows the images very well. I mean, every semester the students, they have to produce these images. So it was the lecturer who actually discovered that, hey, there's something extra in this picture this time round. So that's how they actually, you know, discovered the supernovae, right? Oh, by the way, there's a new question here. So I think this is by Trinket, Mr. Lim Trinket. So he asks, do you regularly maintain the telescopes? I mean, I assume they are exposed to dust or dew or other contaminants. So I think he's asking about your maintenance routine of your telescopes.
Yeah, every scope is cleaned at least once a week. There's someone on site that goes around and makes sure everything is in a really good state with dust, because yeah, if we didn't manage the dust, it would become a problem, especially like if you have dust and you have a night where there's dew and then dust after the dew, you get, you know, water spots and like streak marks across corrector plates. Yeah, we keep everything very clean. Basically all the scopes look almost like they're new all the time.
Oh, that's great. Great maintenance. Okay, I see two more questions here. So this question is by Chia Wen. So they ask, is the on-site team able to help turn on the physical power button of the scope daily after we shut it down, or we need to install remote mechanical button pushers?
Depends on the setup. I would say there's not frequently setups that require a button pusher. The sea stars used to require a button pusher, but most things can be managed with just a remote power switch. So I'd be curious about what the piece of gear is that needs a button pusher. But we would make it work with the button pusher if it came to that. We also would do a daily turning on and off, but if it came to that, we'd probably just, you know, get the person a button pusher so we didn't have to do it anymore.
I see.
Most likely.
All right. So there's one question from Chen En, Tam Chen En. Okay. So is the observatory open for student groups that are interested in astrophotography to visit? So I think this means a physical visit to that place? Is that an option?
Yeah, we have people visit all the time. You just have to schedule it with we have an email, I think, customer support or support at starfront.space. You can contact us through our website and, set up a time to come and visit and see the place in person. But yeah, we have people coming like every week to come see the site.
I see.
Mhm.
I see. Wow, that's great. Speaking of visitations, I mean, okay, I saw that you mentioned earlier on that we could rent the Sea Star for, is it a USD 99 per month? Is that so? I assume that when you rent it per month, you have to try to use it as often as possible to make it right. I mean, do you have like day charge? I mean, like for example, instead of a monthly charge, do you have like sort of like a weekly charge or like a day per day charge kind of thing? I'm just curious.
Currently, no, but maybe in the future, yes, we might do something like that. But right now, it's just the one-time monthly.
Okay. I see. Because
John, I made a comment here.
Yeah.
Whenever I go to an individual's observatory in Malaysia, I'll tell the visitors that you're looking at here an astrophotography machine, one telescope. Well, what you have in Starfront is 960 telescopes, hopefully all working at the same time. So it's actually an astrophotography production factory. It's a factory. More than 1,000 telescopes working at the same time. And that means every night there will be, I don't know how many gigabytes and gigabytes of data. So I was thinking, I don't know whether this is my suggestion. Our Astro Society of Penang annually conducts our society's astrophotography contest, where we select the best one and we put into our calendar for the coming year. So I don't know whether Starfront will collect the best picture, and maybe you can either you can put it in your website so that the people of the world can see what type of result you can get from Starfront. It's actually amazing. 1,000 telescope taking pictures in one night. Not only pictures, John, videos. Some of them could be videos also. And the data is a lot of data they have. Yeah. The biggest in the world. Yeah. And if they build Starfront South, that'll be double. And the advantage on Starfront South is America is in the Western Hemisphere, Australia is in the Eastern Hemisphere, so they cover for both hemispheres. So you observe a transient event, something is happening to a star now in Texas. 12 hours later, you can observe in Australia. You can see the continuation of it. So if you can put this type of observatory at 3 places in the world, 120 degrees space out, you cover it the whole day for the whole year. Like that.
That would be ideal.
That would be ideal.
You also get
you
get daytime imaging as well,
Yeah,
which
I would say
you want to work more with schools and stuff, and you can't teach astronomy to most schools at nighttime, but being able to do it in the daytime instead
yes.
would be transformative, I think.
Yes.
Yeah. I think it could be used. Oh, okay, go ahead.
Always on.
I see.
So the AC is always on. The people choose usually to keep their scopes on all the time with the remote power outlet. So if you didn't have a way to cycle the power, then your scope would be always on. But we usually suggest, people have the ability to control it over the web. They can turn it off as needed if they're not using it. It's up to each user is how it's controlled. Most people, they use mounts that are automated and computerized, so they aren't always tracking when there's power on, but they could have, a park feature where they stop themselves once the observing run is done. Even if it's powered on, it'll stay stopped.
Okay.
Any more questions, Dr. John?
Yeah, so that is all the questions that I have on YouTube so far, right? And I kind of exhaust all the questions that I wanted to ask as well, right? Anyone else here that do you have any final questions to ask?
My comment now is that from the eye telescope setup in Australia to Starfront is a big leap. Now we are close to 1,000 telescopes. So this is really great, and I'm sure this remote observatory at this scale will have a big good future in the future. So on behalf of the Astrophotography Society of Penang, so we wish Bray Falls and his team and Starfront to have further success in the future, and we will follow eagerly what happened in Starfront Observatory South. But we are very keen to see if we can help in promoting Starfront Observatory South. Because they are closer to us, and maybe we can visit Starfront South. And Starfront South, if they are able to host it in near to New South Wales, Kona Barabran, near to the astronomy town of Australia, we Malaysians can visit also. So wish Bray and Starfront Observatory all the best in the future.
Yeah, thank you so much for having me on, and you guys definitely need to come out and visit once we've built down there. It'd be great to see you all in person.
Yes. Anything, Michael?
Okay, just curious about the upcoming project in the Australia. So I wonder, for remote observatory, does it matter the distance away from the users? Like, for example, if you have one in Australia from Malaysia, does it matter whether we choose Australia over Texas or Texas over Australia?
No, it would just be up to you and what you wanted to take photos of. Essentially, both would work fine for remote imaging. It's really just probably what you would want to consider with objects and time zone, like when you actually start your telescope. I think Australia is a lot closer in time to you guys, so it might be more natural to start the scope at night. But if you wanted to run the scope in the daytime, then Texas might be more fun.
Anything from you, John?
No, I have all my questions answered.
Yeah.
It's a very informative session, so I really thank you, Bray, for this.
Yeah.
Okay, is that all? There are no more YouTube questions, I guess. So I suppose that we could end the session. Yeah.
So thanks again to Mr. Bray Falls to giving his online talk on dark skies on demand by this Starfront Observatories. And also, please express our thanks to Miss Sophie Kessner, who sent us a letter to express the interest that Mr. Bray can give us this very, very fantastic talk. So thank you very much again. Thanks to Sophie. Yeah.
Thank y'all for having me.
Okay. Yeah. That's it.
Thank you.